Okay, let's talk about one other thing with confidence intervals. I just showed you how to make a confidence interval based on some data, but a natural question that you should be asking is, how do we know how many people we need in our sample? Okay, how do we know? Obviously, the more people we have in our sample, the better our results will be because it's more representative of the population. Excuse me, especially if it's a true random sample. But how do we know how many people we need? Well, I've got a formula for that. If you look back over here, one thing that you do in real life before you even construct a confidence interval is you figure out how many people need to be in the sample. So check out, I'm constructing a confidence interval, and you'll notice a little arrow here coming down to I need n. I need n. In other words, I need to know how many people are in my sample. The next question is it a mean or is it a proportion? And hopefully by now you know that we're doing a proportion. So these two formulas are both going to be in section 7.1. Now, why do we have two formulas? The reason, in fact, let me box those. The reason we have two formulas is because either we know or have an idea of what p hat is, or we don't know what p hat is. Here's what I mean. Let's say you're doing a survey and there's already been about how many people have a treatment for cancer or something, and you know that the answer is, previous research has said that the answer is 78%, then that means you can kind of assume that that's the answer, 78%, and use this formula. If you have no idea the answer to your question, you need to use this formula. Now notice that the only difference is we've replaced p hat q hat with 0.25. Here's the idea. Do you remember when we were talking about binomials and we figured out that the maximum dispersion, the maximum standard deviation occurred when p hat and q hat were both 0.5? Do you remember that? Like if you were taking a basketball shot, who's the most unpredictable? Well, somebody who thinks 90% of them, that's pretty predictable because they make it so consistently. But somebody who's 50-50, that's like flipping a coin. That's the maximum uncertainty you can have. And so that's where this 0.25 comes from. It comes from p hat and q hat both being 0.5, which 0.5 times 0.5 is 0.25, and so that creates the maximum amount of uncertainty. And so 0.25 is the maximum amount that p hat times q hat can be. And so that's, if you don't know what your population is, you put 0.25 in there to make it the worst case scenario you can. So in general, this number should be smaller than this number. Anyway, that was a really lengthy explanation. Let's do an example so that we can understand what we're talking about. In a study of government financial aid for college students, it becomes necessary to estimate the percentage of full-time college students who earn a bachelor's degree in 4 years or less. This is absolutely critical for colleges. If they are not graduating students, then they can lose their accreditation. Find the sample size needed to estimate that percentage. Use a 0.05 margin of error and use a confidence level of 90%. Okay, let's actually look at the formula. Here's the formula. It's n equals, and make sure you print this out so you can see it. It's n equals, we need to know our confidence level, we need to know our p hat and our q hat, or our 0.25, and we need to know our margin of error. Here's the idea. You hire me to be your statistician because you're running for mayor, and you want me to do a poll for you to find out how many people are going to vote for you, and then you tell me I want it to be plus or minus 3%. In other words, I want the confidence interval to have a margin of error of only plus or minus 3%. So, 0.52 to 0.58 maybe, or something like that. I say, okay, and then I use this formula to figure out how many people I need to guarantee that margin of error. You see, and the smaller your margin of error, the more people I'm going to need in my sample, and it gets big pretty quickly. So, let's do part A. Assume that nothing is known about the percentage to be estimated. Okay, assume that nothing is known. That means we're going to use this formula right here, because we don't know what our proportion is, so we're just going to use this formula. So the formula is our sample size is equal to z alpha over 2 squared times 0.25 divided by e squared. All right, that's the formula. If nothing is known about the proportion, then we use this formula right here. Z alpha over 2 squared times 0.25 divided by E squared. So let's plug in our numbers. 90% confidence level, we do this part exactly the same way. All confidence intervals are 2 tails, so we come down to 90%. That's 1.645. So Z alpha over 2 is equal to 1.645. And now we just need E. The margin of error, they tell us, is just 0.05. Okay? That's it. That's all we need in order to figure this out. So it's going to be N is equal to, whoops. On the bottom, we have 0.05 squared. That's just my E, 0.05 squared. On the top, I have 1.645 squared times 0.25. And that's it. You just plug in your numbers. So if I grab the calculator, it's 1.645 squared times 0.25. That's my numerator. I'm just going to hit enter to get that number. And now I divide that. I'm going to put this part in parentheses, divided by 0.05 squared. So that's my numerator divided by my denominator. You can do it a different way in your calculator as long as you get the right number. So we get 270.6. Let me just check that that's correct. I believe it is. Now, there's one important thing about this that you need to know. And the important thing about this that you need to know is that when we're doing this, we always need to round up. We always need to round up so that we are more than careful. So even if this was 270.1, we would still round up to 271 because we need to be overly careful when we're doing this. So, and you'll notice that in the cheat sheet, I even mention always round up. Do you notice that? Always round up when you're doing this. So that way we're extra cautious. We definitely will get that margin of error that we want. Okay, now let's do this problem again. Assume that prior studies have shown that 55% of full-time students earn bachelor's degree in 4 years or less. So 55%. Well, on this one, we actually are making a guess about the 55% right there. And so that we can use this formula. So instead of the 0.25, we have p hat and q hat. So this time the formula would be z alpha over 2 squared times p hat and q hat all over e squared. Okay? This time p hat would be 0.55. Q hat would be 1 minus that, which would be 0.45, like usual. Our z alpha over 2 would be the same, 1.645, and e would be the same, 0.05. So the only thing that changed is now we have p hat and q hat. So let's plug that all in. 1.645 squared times 0.55 times 0.45. That's going to be my numerator, divided by, parentheses, 0.05 squared. So again, you can do it slightly differently for your calculations and as me. And so remember, we get n equals 267.89. Remember, we have to round up. So 268. Always round up. Even if it was 267.1, you would still always round up. So notice that if we make an assumption about the initial population, that we can survey a couple fewer people, not that many fewer because 55% is still really close to 50%. So you're not really saving that much, but if this p hat is really high or really low, you can save some money by surveying a lot fewer people. Although it's always dangerous to build your whole confidence interval off of an assumption. And if your confidence interval was different than 55%, then you should be concerned. Or if it was far away, I mean. So, does the knowledge added in Part B have much of an effect on the sample size? I would say no. You're only shrinking it by 3 people. So, yeah, I would say using the additional survey information only slightly reduces the sample size. So we're only, this is kind of a judgment call, but if you're only saving 3 people, that's not that's not a huge saving. So I believe that this is correct. Let me go ahead and pull this up. Again, the main thing to remember when you're doing this is that, yes, all of my answers are correct. The main thing to remember when you're doing this is that always round up when you're finding n. You always round up to guarantee that margin of error. Okay, hopefully that's enough explanation. I will see you in the next video for section 7.2.